We're talking about position, velocity, and acceleration. We have the problem here. A happy, crazy person jumps off the Chrysophyllae Bridge into the bay. A man standing on shore who witnesses the event claims it took him 7 seconds to hit the water. So I guess he had a stopwatch rolling and was waiting for the dude to jump and figured, I don't know why he wanted to know that, but he was a happy, crazy person. Where in the world is this at? The Chrysophyllae Bridge. I don't... Huh. Into the bay. Okay, whatever. Let's see. It says, how high was he from the water? So we want to answer that question. And we're only given that it took him 7 seconds to hit the water. So that would be interesting. And what was his velocity when he hit the water? Ooh, bet that hurt. All right. How high was he? All right, let's look at what we had to do here. And actually, I'm going to start with just looking at the graph this time. So, of course, to get this graph, we're going to have to come up with the position function. But let's say we're given the graph. We can tell by just looking at it, right? So somewhere between 200 and 250, that was the height that he jumped off the bridge at. The height from the distance from him and the water. And that looks like about how long it took him between, that looks like 7 seconds. Well, that would be 7 seconds, right, when he hit the water. And of course, this line right here represents the velocity, and it's negative from time 0 on up, well, to infinity, but we're only concerned about right here. I guess to find the actual velocity, you would take 7, go here, get a straight edge, come straight across if we were trying to do this, come up with this graphically. But I guess we got to actually come up with some functions here. So the first thing we want to do is we want to answer this question here. How high was he from the water? Well, here's the position function that we're going to actually use, which should look familiar. And if I plugged 7 into this thing, which I don't know why there's a 7 there. Let me get rid of that. Whoops. Okay, that should be a D. So here's the position function. Now his initial velocity is 0, right? And at some height, this is his initial height here. And so if I plug 7 in to our function, now what's v sub naught? Well, v sub naught is 0. So if I come down here plugging 7 in, right, and what we're going to do here is we're going to solve for s of naught. It says how high was he from the water? Well, if his height here was 0, right, that's what s represents, s of t represents the height. If height is 0 and we plug 7 in now, all we have to do is solve for s of naught. And so I go ahead and do that, taking this stuff over to the left-hand side, whatever. And we end up with, he was 240.1 meters above the water. So that's pretty high. Now keep in mind that there is some kind of error because there's got to be some kind of reflex when this guy actually took his stopwatch and hit it. So it may not quite be this number. It may actually be a little bit smaller. And I don't know, that's just my guess. But remember, this is just a model here. Okay. So he was 240.1 meters, I just round to 1 decimal place here, above the water. All right, we got another question here. What was his velocity when he hit the water? Well, we know how long it took him to hit the water, so you just take the 7, plug it into the velocity function, and he was traveling at 68.6 meters per second. Remember what the negative is. The negative means that he was going downward, right, towards the water. So that's pretty fast. I bet that hurt. Bet he doesn't do that again. But remember, he was a happy, crazy person on some strange bridge. I don't know where that was. All right.